low carbohydrate, low sugar diet seems to be the most beneficial. Tim, why is that?
Because it's the diet that humans evolved with. And I know we're going to a global audience, but yesterday I saw a lovely slide that 22,000 years ago, all of Europe, most of Europe and most of North America was under a kilometer of ice. So how could you grow carbs 22,000 years ago? You either ate something else or you died. And the reality is that for the last 2 million years at least, humans have been eating a high-fat, high-protein diet. And that's what we evolved to eat. And then we were doing very well until along came the new dietary guidelines, which were driven by the food industry. And that was 1977. They came along 1977, and we got this pyramid with lots of grains at the bottom and meat at the top. And that was a complete distortion because that's not what humans were adapted to eat. So we started eating that diet, and now currently something like 60 to 80% of North Americans are suffering from metabolic syndrome, which is caused by excessive fat accumulation, particularly in the liver and the intestine. And that's where we are now. And fortunately, with Trump coming along and Robert Kennedy Jr., they're desperately trying to change the food environment in the United States. And that's what we have to do. We have to reverse it to where it was. When I was a child in the 1950s, I grew up on bacon and eggs for breakfast because that's what my parents had eaten when they were living in Liverpool before they came to Africa. And that's what they were brought up on. And they'd been brought up on that because they came from the north of England, and the north of England had, I suspect, been cold and covered with ice for many centuries. And so the people who survived there or went back there ultimately were going to be eating animals.
Tim, you spoke about when you were young. Would you mind taking me through your journey and how you got to where you are now?
Yeah, well, I was born in Zimbabwe, and then we moved to South Africa when I was 5 years old. I went to school here. I finished my schooling. I had no idea what I wanted to study, absolutely none. I was fortunate to go to America for a year on an exchange program. I was fortunate that Professor Christian Barnard performed the world's first human heart transplant on the mountainside here at the University of Cape Town at the hospital, Groote Hospital. And 3 months after he performed that operation, I woke up one morning and said, I'm going to study medicine at UCT. I studied medicine at UCT. I very quickly realized that my interest was more in exercise physiology. So when we were studying medicine, I was studying the exercise physiology side of it. When we were studying medicine, I was looking at the sports medicine side. I somehow convinced the guys I knew enough about medicine, so I got my degree. I did a year in the hospital so that now I could practice medicine. But I realized I just wasn't cut out for this. I was not someone who's good at managing patients. I'm really good at looking at the literature and finding out, asking questions and working out what we should be doing. So in a sense, what happens in medicine is you reach a point where now your career must divide. You've got choices. And if you're intellectual, if you're a surgeon, it's fantastic because then you go and practice with your hands and you really cure people or you make them better. But if you're a physician, it all comes down to what's in your head. And the more you know and the more your brain can retain information, the better you are the better qualified you are as an academic. Doesn't mean you can manage patients. And I realized I didn't want anything of that. And so I was fortunate. I was competing athletically at the time, and I just loved it. And I remember we had one lecture, because I was actually rowing at the time, and the coach of the British Olympic team just happened to be in Cape Town, and he happened to give us a lecture. And he spoke about lactate causing you to get fatigued during exercise. And I came out of the lecture and I said, that's what I'm going to study. And so that's what I did. So I studied sports science. We started sports science in South Africa. We helped drive sports medicine. And I spent 40 years researching in sports science and sports medicine, both on the practical side, how do you help athletes perform better, and also on the scientific side, trying to understand all these factors. And I think probably I'm best known for writing a book called Law of Running. and that's called the Bible of the sport. And as I told you before, I'm now revising it for the 5th time. The last time I revised it was 20 years ago. So what happened in the last 20 years, which sort of drove me away from sports science, was I got interested in the low carbohydrate diet, and that's how I could help you. But that caused me to be basically excommunicated by my university, and I was tackled by the the Health Professions Council in South Africa, and they charged me with unconventional advice and not evidence-based medicine and so on, because I tweeted and I advised a mother to. No, I didn't advise a mother. I gave general advice to the population that the best way to raise a child is on a high-fat, high-protein, animal-based diet. And we even wrote a book about it, Raising Superheroes, which is probably the best book I've ever seen on how you should raise children and what food they should eat. Anyway, I was charged by the Health Professions Council. It took 4 years. I was in court for 28 days, and we eventually won the case. And there were 13 charges against me. I won 13-0. And so that sort of, during that period, I had to learn nutrition because or health nutrition. I wasn't an expert on health nutrition. I knew a little bit about sports nutrition. So anyway, after that, a great friend of mine, who's now a great friend of mine, ex-South African living in America, he said, "Prof, I've got this lab. Wouldn't you like to collaborate with us?" And he asked, what should we study? And I said, we should study low carbohydrate diets and their effects on performance, which we did, because at the time it was said that a low carbohydrate diet destroys your performance. And in science, that's what you must look at. You must go and disprove your theories. So historically in Law of Running, up to 2010, I'd said that the high carbohydrate diet is ideal for exercise. I then converted to a high-fat diet, and my exercise performance went through the roof because I was sick at the time, and so I got much better. And that made me question the teaching. And then so when I started writing, and people then claimed, "Oh, you've changed your mind." Well, you always change your mind when you see new evidence. Anyway, so I wrote. So we started doing research, and we did fantastic research. It's taken 7 years, and essentially in the last few months, we've published the definitive paper, which disproves that you need carbohydrates you don't need carbohydrates for exercise. You just need a tiny amount during exercise. But before exercise, what you eat makes no difference to your performance, which is completely contrary to what I was saying and which is currently taught. And that's because we evolved on a high-fat diet, and we had to exercise on a high-fat diet, or else we would have died. And our bodies are highly designed to burn fat. But what's happened is that when we converted to this high carbohydrate diet, we always got a high insulin levels, and insulin inhibits fat use by the body. And so when all the studies were done by ourselves, including on athletes, as soon as you put an athlete eating a high carbohydrate diet onto a treadmill or a bicycle, they're immediately burning most of the energies coming from carbohydrate. But it's not because that's the best fuel. It's actually because they're trying to get rid of it. But that's a whole nother story. And so we started saying, well, you've got to eat more carbohydrates. And I mean, we spent 20 years trying to get people to burn more carbohydrate. And what that does is they burn lots of carbohydrate and then inhibit fat. And so then we say, well, it's because they're burning carbohydrate that they're doing well. So when we started working with this group in America, I said, let's do the opposite. Let's make them burn fat and see what happens. And we found that it made no difference whatsoever. They could burn all the fat they liked, and they could do all the exercise they wanted. And there's very good reason to believe that for the average person, they're much better burning fat than carbohydrates. And I don't really see any role for high carbohydrate diets in athletes at all. Although I'm on Twitter every day and I get castigated for saying that, because all the world's best athletes are taking 120 grams of carbohydrate an hour. Now, when we as doctors want to see whether you've got diabetes, we give you 75 grams of carbohydrate. So these people, every hour, they're doing a glucose tolerance test, which we use to see whether you're sick. And now they're telling me, no, that's the way we make you a better athlete. Just explain that to me. I can't follow that one.
But just to be clear, and I think you might be being a bit modest here, but when you talk about sports science, you effectively the world's leading sports scientist, or number 2 or something to that effect. You're very, very high up.
Yeah, that's on the citation rates. In other words, the number of times your articles are referred to. And about 2 years ago, I was 3rd, and then the 2 guys older than me both died. So I haven't seen the latest results, but I don't think anyone would come up below me from below up. So I'm probably number 1 or maybe number 2 if someone else has suddenly increased their citations.
I bring that up because you do know what you're talking about, but you are talking about sports. Does this flow over into general life?
Yeah, I think so, very much so. Well, I can give you a good explanation. So when I started in the sports sciences, the one thing we were told was that lactic acid causes fatigue in your muscles. That's exactly what the coach told us when he lectured to us in 1969. And that's the textbook knowledge. And I was speaking to a group of schoolboys the other day, and they said, yes, that's what we have to write in our examinations. And I said, but it's all wrong. And I said, you can prove it's wrong. All you have to do is just go and watch a 10-kilometer race and time each lap and tell me which is the fastest lap. Now, according to your theory, the first lap must be the fastest because you've got no lactate, and the 10th must be the slowest. And I said, what you're going to find is the 10th lap is the fastest. So how can it be the fastest when the lactate levels are the highest? So therefore, you've disproved the theory just by simple observation. So what happened to me was I went and looked back at some of the literature on which all of this was based. And it goes back to a guy called A.V. Hill, who was from Cambridge and elsewhere in the 1920s. And he said that when you exercise vigorously, you reach a point where there's no more oxygen getting to the muscles, and that causes you to stop exercising because the lactate builds up. And I'd come to the conclusion that that was wrong and that he'd never actually shown that. And then I was heavily criticized for this was a major lecture I gave in America, and it was a named lecture. And so when you write up the story, not everyone writes up the lecture, which I did. And the funniest thing was that somebody responded to it, which never happened before. And I was in Finland, and it was with the Paavo Nurmi's 100th anniversary. And I was speaking about Paavo Nurmi because he appears in Law of Running quite a lot. And that's why the Finns really liked me, because the book includes a lot about their greatest runner. So just as I'm about to get up, my great friend who'd invited me gave me the journal, the scientific journal, in which this criticism was listed. And I literally standing up and says, Tim, you might want to read this before you say anything. So I said, no, I'll look at that afterwards. Anyway, when I went back and read what he had said, Professor A.V. Hill, he made the key point that if you run out of oxygen in your muscles, the first organ that will be damaged is the heart, not the muscles. The heart comes first, then the muscles. And he realized this, and he said there was a controller or a governor that went from the heart to the brain to slow the heart's function down. And I immediately knew that couldn't happen. It has to go to the brain to slow the muscles down for various reasons. And then I realized that this governor theory, which we then developed, is that during exercise, the brain's designed to protect you from harm. And everything that all this information is coming back to your brain, and your brain then allows you to run at a particular speed which won't cause harm. So it projects ahead. So if you're going to run 100 miles, it projects ahead for 100 miles. It says, okay, you can start at this rate and you'll be okay. And if you try to go above that, then it'll slow you down, etc. So that was the model, and we developed it. And I was it's been pretty much accepted now. But it's really interesting because now the premier journal in physiology journal in the world says, published a new paper this week or a few weeks ago, again saying that the heart limits exercise performance, but it can't, because if the heart's limiting, it's going to go into heart failure. So you have to have another mechanism. So A.V. Hill's theory, which we disproved in the 1920s, is still very popular in 2025, 100 years later. And that's science. It takes a long time to overcome these ideas.
You're speaking about in the 1920s. Just to clarify, when we talk about low carbohydrate diets, we're not talking about a fad.
No, absolutely not. I mean, it was so we've published now a textbook. I don't have a copy of it, the ketogenic textbook, in which we got 60 of the top scientists in the world who study low carbohydrate diets. And the point I'd like to make is that all 60 of them came to the diet the same way I did. We were promoting high carb diets. That's great. You can run faster and you're healthier and et cetera, et cetera. And then we each became sick ourselves. I developed type 2 diabetes, which fortunately is in remission with this diet. But so we all developed a problem, became fat and lazy and lethargic and depressed and anxious, et cetera. And then we discovered this diet by different chances. And we all got better on the diet. And then we realized there was something special to it. And so anyway, these 60 scientists around the world, we've put together this textbook. And it shows the low carbohydrate diet is the most studied diet in history. And it's the most successful because it covers all these conditions. So that's the evidence.
Yeah, so that book you're speaking about, if I'm thinking of the correct one, Thomas Seyfried is in there, isn't he?
That's right. Yes, absolutely.
And Thomas has written extensively on cancer and why you help fight cancer with low carbohydrate diets, and that is fairly established anyway.
Oh yeah, I think that's absolutely right. I think that if you had cancer, the first thing you do is go on a low carb diet, but that will slow the growth of the cancer. It may not cure it, but the cancer is undergoing a huge revolution because a lot of the drugs are being repurposed for treating cancers, and ivermectin is one of them. And it's remarkable that this drug is having some incredible successes.
I was reminded of the time that you and I met, and I told you I was suffering from heartburn, and you said that the oats are linked to that. Tim, why is there a connection between heartburn and carbohydrates?
Okay, so what happens when you change your diet is you change the microbiome. And what is found with carbohydrates is that the carbohydrate digesting bacteria move up higher into the small intestine. They shouldn't be there, but they make their way up. And what happens then is when you eat carbohydrates, they break down the carbohydrates and release methane. And because it's up in the upper parts of your gut, where is it going to go? It's going to go up. So you're going to burp it up, and that is going to take acid from the stomach into this lower parts of the esophagus. And repeatedly done, that causes irritation in the esophagus, and that causes your persistent pain or repeated pain whenever you eat or when you burp, and this acid comes back into the esophagus. And what's interesting is that the treatment which they give you to increase the alkalinize your stomach is disastrous. It makes things worse. So the only thing you can do is to get rid of those bacteria. You don't want them. You've got to reprogram the bacteria in your gut. And that's what it seems to be that the high-fat diet does particularly.
So by extension, a lot of people will argue that it's sugar that is doing that.
Yeah, it may well be. And so, but let's make it simpler. Let's say it's ultra-processed foods because they're the real problem, and that we need to go back to eating real animal foods and get away from ultra-processed foods. So, but you're quite right. A lot of the ill health has happened with ultra-processed foods. All of it has happened subsequent to ultra-processed foods, and we tended to focus on the carbohydrate components, but there may be all sorts of other things in the foods that are causing the problem.
What really matters is we must just eat less processed food and just be more balanced.
Yeah, the word balanced. I mean, I don't know what balanced means, because that's the standard dietary advice. You must eat a balanced diet, but I don't know what a balanced diet is. Is it a third fat, a third protein, a third carbohydrate? No, the reality is, and this is what one has to learn, particularly if you're like me, is that there's only so much carbohydrate you can cope with. And some people can cope with plenty of carbohydrate, but others like myself can cope with less than 25 grams a day. Now, what is 25 grams compared to the normal? So most South Africans, probably most people living in Britain and Europe, are eating maybe 400 grams of carbohydrate a day. And what we discover is that if you drop your carbohydrate intake from 400 to 300, it makes absolutely no difference whatsoever. So you might think, gosh, I've reduced my carbs a lot. But you have to, when you're in my state with pre-diabetes, diabetes, you got to get it down below 50 or 25 grams, which is, well, I don't eat these things, but it's a couple of slices of bread or banana or an apple, and that's it. And when you start, it's difficult. I've been on this diet 15 years now, and so it's not a problem. But initially, to think that, my gosh, you've got to cut from 500 or 400 grams down to 25, it's quite a leap. But once you start it, you just feel so much better, and everything goes well.
If we zoom out, what you effectively arguing is that there is no requirement for carbohydrates in order to have optimal health.
Correct. There are proteins are essential. There are certain amino acids that are essential. There are certain fats that are essential. And if you avoid them or don't eat them, you will die. That's as simple as that. There is no carbohydrate that is essential, none at all. And, people say, oh, you need fiber, etc. But the fiber is just broken down to saturated fats and absorbed as saturated fat. It's not even absorbed as carbohydrate. So then what the dietitians tell us is, but your brain uses only carbohydrate. And so therefore you've got to eat carbohydrate. But that doesn't understand you've got a liver. You've got a liver that's there to produce the glucose you need. And the liver can produce both glucose and ketone bodies, which will keep your brain going fine. So we have shown that there is an essential carbohydrate requirement, and that's during prolonged exercise, because then for some reason the human body is not designed optimally, and I'm not really thought of why it should be, but if you eat a low carbohydrate diet, so you're eating zero carbohydrates, and you exercise for a long time, you may reach a point where the liver can't produce enough glucose from other substrates. And then your blood glucose level can fall, and you'll feel a bit woozy, and you'll want to stop exercising. And that's it. And that's because clearly the brain does have an essential glucose requirement. But the only time you really see that is if you're going to go and exercise for 3 or 4 or 5 hours, and you're going to fast and you don't eat any carbohydrates during exercise. And that's where you will see, yes, there is an essential glucose need. But what we proven recently is that you just need about 10 grams of carbohydrate every hour. And that covers that requirement, which is a tiny amount. So if you were to go and run a long distance race, you weren't eating carbohydrates, you were on a high-fat diet, during the race, you could benefit from ingesting 10 grams of carbohydrate. And that's because, for some reason, the brain's glucose needs remain high when you're exercising. And sometimes the liver can't produce enough glucose to keep the brain happy.
Okay, but the average person doesn't weigh his food. So what does this mean practically? If we go to dinner, vegetables have carbohydrates in them, potatoes. What do you mean when we talk about low carbohydrates? Just in standard daily, living?
Yeah. So I think it's easy to explain. It's the easiest way to explain is what can you eat? That not what can't you eat. So you can eat all animal produce, all chicken, fish. You can eat dairy. You can eat some nuts, but not all the nuts, and lots of eggs. And some of those green vegetables, the leafy vegetables, because they're so low in carbohydrate, that's fine. And that's it. so So where do potatoes come? Where do they don't fit? Unfortunately, don't fit on that group.
Nor do carrots.
Where does bread fit? Doesn't fit. Where does carrots? They don't fit. But again, a carrot a day is not going to cause harm because it's not going to have more than 25 grams of carbohydrate for a diabetic. And if you're not diabetic, you can have your 50 to 100 grams. So I think what we're talking about is for the people whose metabolism is so damaged they can't cope with carbohydrate. And those are people with type 2 diabetes or pre-diabetes. Now, the problem is that what's happened, now my mother would have eaten a high-fat, high-protein diet during her pregnancy with me. I would have been weaned onto animal produce. I wasn't given baby puree foods. I would have been given proper meals with animal produce. So my insulin resistance was entirely genetic. It's all throughout my family. And as long as I ate as long as I ate fats and proteins, I was fine. And I did that for a long time until I started marathon running. And then I was the expert now. I mean, I'm reading all the physiology, and the physiology said you must eat carbs. So I started eating carbs, and that's when I started getting sick without realizing it. And if you do that for 30 years, as I did, then ultimately you can present with type 2 diabetes. The irony is my sister, who probably has very similar genes to me, she was in London in 1965 and she picked up a book. And I think it was called The Drinking Man's Diet. And that was one of the first low-carb diets. And she went low carbs. And she looks amazing. And she's 80 odd. She's close to 80. And she's still as lean as ever and amazingly healthy. And so she told me, eventually, she admitted, she said, Tim, I've been eating your so-called Banting diet for 40 years. So I said, well, why didn't you tell me? She said, no, you're the expert. I couldn't tell you.
But that's an interesting point that you're making. So I, for example, I'm not overweight. I could eat a carrot a day, for example, and it won't really affect me. But there are a lot of fat people around us. And what you speaking to, more to them.
Yeah, absolutely. So if you've got this beer paunch, that's called visceral obesity, and you are pre-diabetic or diabetic. I don't care what your glucose test shows, and that's unfortunately the glucose test isn't adequate. And I've just written the foreword for a very famous book by a guy called Dr. Kraft, who did some amazing work in the 1970s, and his son has had the book republished. I'm sorry it's not quite at hand here. And what Dr. Kraft did was when the insulin assay was discovered, where you could measure insulin levels. His hospital was doing all these glucose tolerance tests in which you only measure glucose. He said, well, why don't we measure insulin on all of these tests? And so they measured 15,000 tests where they had the insulin and the glucose. And he found essentially that a normal glucose tolerance test, which we as doctors would say, oh, you're perfect, you haven't got pre-diabetes. It's a no. Let's look at your insulin response. And if the insulin response was abnormal, you were going to develop diabetes. And so that was the test. And unfortunately, that test is not done. We still don't do it. We still just measure glucose. So we completely underestimate the extent of diabetes in the population. We know it's an epidemic, a pandemic. We know it's the single most important disease because it causes all the sorts of complications. And yet we still don't diagnose it early enough, and we don't prescribe the proper treatment. So that's the story with diabetes. And now if we were to take everyone who's got a pot belly, and now that's normal, that's accepted. So even the models now, you can have a fat tummy. But that is visceral obesity, and that is killing you. The fat cells in the gut are releasing inflammatory agents, and they're causing you to become insulin resistant, and then that causes all the complications of this disease. So that's the reality, and we just ignore it.
So just to be clear, running and more running is not really going to make you lose weight.
It'll do the opposite because you're told to eat carbohydrates. So that's my real frustration is if you go and, when I started marathon running, if you didn't finish in 3 hours, there was no one was there to greet you at the finish. You had 3 hours to run the marathon, and then they closed it. Now you can take 10 hours to run the marathon. And of course, you're not running, you're walking most of the time. And so it's clear that the performances in the marathon are getting worse. The best runners are running faster, but the average time is getting slower and slower and slower and slower by decade. And so what's happening is people are thinking they're becoming marathon runners. They're not training. And then they go out and then they're told, well, if you want to finish the marathon, you better eat lots of carbs. And they're insulin resistant, and it's just making it worse. So if you go to the finish of the London Marathon, not the Boston because it's got an entry time, but the New York City Marathon and all the other big city marathons, after about 4 hours, you see these pot-bellied humans coming in. And they think they're healthy, but they aren't, because you can't outrun a bad diet. The bad diet is because you're insulin resistant and because you've got a high circulating insulin all the time, that's causing all the damage that is possible. So that's the message we have to get out. You can train all you like, you can run all you like, but if you're insulin resistant and eating the wrong diet, it's not going to make any difference at all.
So weight loss starts in the kitchen.
Absolutely. And I didn't know this, even though I wrote these books. But one of the studies we did was about 30 people wrote to me and said they'd reversed their diabetes, their type 2 diabetes, diagnosed by the doctor. They'd reversed their type 2 diabetes on this diet. And so that was great because I knew it was happening. There's a guy called David Unwin in Britain who is now he's in a general practice. He's had 150 patients reverse their diabetes just on diet, nothing else, just diet alone. So we knew it was happening, so we thought, well, let's just check up to make sure that these people is true. So we asked them all, we examined them and did everything you need to do. And we found that some actually hadn't reversed their diabetes and they hadn't lost as much weight as perhaps they claimed they had. And when we looked at it, the one factor that determined whether you reversed your diabetes was whether you stopped your cravings and you controlled what you were eating. If you didn't control your cravings, you didn't reverse the diabetes. So it wasn't about controlling glucose, it was controlling your cravings. So then we realized, okay, we've got an addictive process. And not that we were the first to think that the foods, the ultra-processed foods with lots of sugar are highly addictive and they're designed to addict you. And they're designed because the people selling you that food were once the tobacco manufacturers and now they're the food manufacturers. And they know how to develop addictive foods. And so that's what they've done. So if you want to lose weight and control your diabetes, you have to control the addiction. And it's across the board. And I know when I advise people on the diet, I first ask them, do you drink wine? Yeah, I'll never give up my wine. Then I know it's not going to work. Or I'm not going to give up my beer because that's the addiction that's continued. And you have to get rid of the addictive eating.
Is what you're talking about specific to genetics or culture? Let me give you an example. I was in China last year, and they don't seem like fat people. I saw very, very few fat people.
Well, the answer is, are you Chinese or Indian? Simple. If you're not, you've got different genes and different.
Okay, so there is a genetic thing aspect to this.
Yeah, but now let's look at that. Let's unpack that. The Indian community is incredibly unhealthy because they eat mainly a vegetarian diet and they have too little meat. and they are extremely unhealthy, and diabetes rates are very high. The Chinese are the most obese, and I know I quite agree with you. They're thin, but when you look at the total population, there's much obesity and much diabetes. And this is a recent phenomenon too, because before that, Chinese people they weren't starving, but they were eating low calories, and they were eating below 2,000 calories a day. Now that's shot up to 3,500, and so that's causing the obesity. But I agree, it's not everywhere. And I mean, I've spoken to people from the Middle East, from Iran, and so on, where the carbohydrates were really first introduced, and they remain lean and they eat lots of carbohydrate. So I think they've over 18,000 years. That's since they've been eating carbs, they have adapted in a way, and and it's maybe because the ones eating the carbs who couldn't cope with it died off and didn't recreate and procreate and so on. So I do agree that is right. There are populations, but you just have to look in your own population.
Yes.
You can't go and say, what are the Chinese eating and what are the Indians eating? Just go and look in my country or our country. Just go down to the mall and see what people look like. And do they look like they're thin and healthy? And the answer is no, and then see what they're eating.
It is actually a problem. I mean, I saw photographs from when my folks were kids on the beach, and everybody looked fairly thin.
They were
today,
thin, yeah.
Everybody today is fat.
Exactly right. And that it's simple. It's the food addiction and the ultra-processed foods, which, as we've said, are highly addictive. And you just have to eat a few extra calories a day, and then you'll accumulate that over time. And the idea that you should only eat once a day is foreign to those people. And that's what we try to teach, that once you've got your controls back again, you can fast most of the day. You just don't need to keep eating all the time.
But what's interesting is if I have a big plate of food in the morning, bacon, eggs, sausage, coffee with cream in it, I'm not hungry for most of the day.
Yeah, that's what we tell people. If someone comes to me and says, prove to me that your diet works, I'd say, well, we're first going to do this experiment. And it's astonishing. They all come back and say exactly what you said, and they can't believe it. And so what I try to tell people is you should eat only at home, because then you don't going to eat snacks on all these other ultra-processed things. And you should eat as much as you possibly can for breakfast if you're a working person away from home. And then you go to whatever you do, and hopefully you're not going to be hungry till 5 o'clock at night. And if you are hungry, you eat nuts and biltong, which is...
Hang on, Tim. Yeah. I've got to drop this one in. Yes, but Tim, you're funded by the meat industry. You're promoting meat.
I wish I was. The only thing I ever got from the meat industry was unfortunately it's not here, it's at another place, was a lovely statue of this bull. And it was from the meat board, and that was it. They all said they're going to put up a monument somewhere in the Karoo because I also promote that. It reminds me of Elon Musk saying, he's the biggest taxpayer in North America. He pays $20 billion a year in tax. He said he'd really like it if the IRS one day would come and give him a little placard saying, he said, they've never done that.
But let's just talk about that for a second. I have friends who are vegetarian, and it's always a heated discussion, always, when you're talking about meat. Okay, so let's just quickly break apart this narrative. If your position is ethical, you don't like the idea of animals being killed, okay, that's fine. I can't argue with you on that. That's a personal thing. But if your argument is that avoiding meat is healthier, that is simply not true.
Yeah, absolutely. I think you've absolutely made the divide. And if people want to eat it for ethical reasons, the vegetarian diet, that's fine, but they're going to suffer. Their health's going to suffer. But also the reality is there are very few vegetarians. Most of them cheat. When you look at it, they do eat meat. And then say, no, but I had some chicken or I had an egg, but I'm still a vegetarian because I'm not eating meat. No. So So that's the first point, is that there are truly very few vegetarians. The second thing is that there's always about point, I think it's 0.5% of the population are vegetarian, or maybe that's vegan. Maybe it's 2 or 3% vegetarian, and it never changes. So if this movement was real, if the biology was real, and that you would do better as a vegetarian, the numbers would have increased dramatically. And it hasn't. It's always stayed the same over the last 20, 30, 40 years. It basically is a religion, which is fine. But it's not the healthiest, because you need animal produce to get all the nutrients in the right sort of balance. And once you take just eating plants, and you've got a problem. And the other thing is that once you're not eating animal produce, you think it's okay to have a Coca-Cola and to eat chips and to eat other things like chocolates. Oh, because it's vegetarian, it's vegan. But it's highly unhealthy. And that's the problem. And when you look at the diets of those people who don't really understand it and analyze it and go through in great detail what they should be eating, and it takes a lot of effort, and it's probably a bit expensive too. They're fine, but the average vegetarian doesn't eat very well. And it's the same in sport when the athletes are promoting high carb diets. They think it's fine to take their Coca-Colas and their chips, etc. Oh, because it's carbs and it's going to make me exercise faster. But it's not giving you the nutrients that you need. And that's the problem. It's a nutrient deficient diet.
Could you live quite healthily off purely meat?
Yes, I could. Yeah, you can. I mean, you can. And I certainly could. And in fact, I do mostly.
But I mean, can you get everything you need?
Yes.
All the vitamins. You don't need any supplementation if you just eat meat.
No, but you do have to eat organs. You have to eat livers and pancreas and a few other things, and bone marrow. But you can. I mean, you go and look at the populations that do like the Inuit. They're doing very well. They just eat animals, fish, and animals, seals, and so on. And
there was that guy who lived with the Inuits
yes.
like 100 years ago or something. I forget his name now.
I'll get it too, because you jumped
at
me.
He was Finnish or Swedish or something.
He was living in Harvard in Britain. In North America, and he was an anthropologist. And then he went on a trip to the Arctic. And he decided either he got lost or he wanted to stay there with them. And he then lived with them for 4 or 5 years. And when he came back to New York, he said, "But I've lived on animal produce for 5 years." They said, "No, you'll have scurvy." And he said, "Well, I haven't got scurvy." So they said, "Well, prove it to us that you shouldn't get scurvy." So they put him in hospital for 3 months, and they fed him the diet that he claimed he was eating, and he was fine. They then let him out, but he promised that for the next 9 months he wouldn't eat any other produce other than animals. And at the end of the year, he was fine, and the paper was published. And then that diet stimulated a guy called Pennington to produce that diet and give it to patients in New York who were obese, and that became the Pennington diet, and ultimately that became the Atkins diet, also from New York. So that was the way that the low-carb diet invaded North America. Yeah, and I have to think of the guy's name. I'm sorry, it escapes me for a moment.
No, that's fine. It escapes me too. But then where does this whole cholesterol thing come from?
That comes from a guy called Atkins. Now, what happened in the Second World War... sorry,
Ansel?
not Atkins. No, sorry.
Yes.
Sorry.
Yes, that's right.
So I've got very confused. Atkins is the opposite. This is Ansel Keys. Sorry. Yeah. Ansel Keys, in the Second World War, he did a famous study in which he put religious objectors on a starvation diet for, I think it was about 6 months, and he monitored what happened to them. And it was disastrous. The psychological effects of eating I think it was 1,500 calories. It was absolutely atrocious. Anyway, he became very famous because that was the famous starvation studies. So now he does the study. It's the end of the Second World War. And what happens is that President Roosevelt dies of a stroke. And because he's had a stroke and he's an American, suddenly the next President, Truman, says, but why can't we sort out this stroke issue? And he forms the National Institute of Health, which is now going to fund research. And the main focus of research is to understand, why do you get cardiovascular disease and stroke? Because that had killed the previous president. And so a lot of money became available for doing research. And there was a guy called John Goffman, who in the Second World War, he had been looked at plutonium and uranium and how you separate them. And so he was a world authority on the way you detected chemicals. And at the end of the Second World War, he went back to his university in Southern California, and he started using the same techniques. And he said, why don't I use this on blood? So he took blood samples and he analyzed them. And then he said, my gosh, there's all these ways that fat is carried in the blood. And he then classified these as lipoproteins. And one of them was the cholesterol-bearing lipoprotein. So now he could measure these things, and he noticed in heart disease patients, there were two different types of heart disease patients. The one had a very high cholesterol, and the others had a very high triglycerides. But those are both forms in which fat is carried in the bloodstream. And he noticed those who had high triglycerides were the ones who had high carbohydrate diets, and those who had the high cholesterol had high fat diets. So what he did next was he put people on a low-carb diet and a low-fat diet. And he clearly showed that on the low-carbohydrate diet, the triglyceride levels came shooting down. And on the low-fat diet, the cholesterol came down a little bit. And he concluded, be careful of putting people with high cholesterols on a high carbohydrate diet, because you might shoot the triglycerides up and cause problems. So he was the person who should have led the drive on preventing heart disease. But Ansel Keys came along, and Ansel Keys had no future, and he picked up a magazine, literally, which had a World Health Organization figure. And in the figure, it had 26 countries, and it showed what their fat intake was, the saturated fat intake was. Sorry, it was the saturated fat intake. And he looked at their coronary heart disease rates. This is what the graph showed. And there was a big cluster of their values, but generally they sort of went up a little bit. So the more fat in the diet, the more heart disease in the country. And what he did was he selected out 6, which showed a linear relationship. So from the 26, which were all over the place, he chose 6, which were a lovely straight line. And so he said, there you are. We now know what causes heart disease. It's fat intake, dietary fat intake in the dietary fat intake. And that became the gospel truth. And the point is that a relationship like that, you can't prove. That's not causation, that's association. And association doesn't prove causation. But the whole world was captured. The whole world was captured. And they still are. Because if you ask your cardiologist, how do you know cholesterol causes heart disease? Oh, well, Ansel Keys proved it. And I look at this graph, and that's where they begin with. So that's where the cholesterol story begins. And unfortunately, what next happened was that in about the 1980s, they discovered that there's people with very high cholesterol, and they found a way to lower it with the statin drugs. And they said, well, you see, it's obvious when you've got a very high cholesterol, you die young. And therefore, if we can take statins, these people are not going to die as young, etc. We can prevent heart disease. And I can tell you that's to this very day. There's no one clear bit of evidence that statins can prevent or reverse heart disease. They have a tiny effect, and the effect may be some other way, but their benefit is trivial, but yet they've generated trillions of dollars of income for industry. And so industry makes sure that the story continues to be kept going. The problem is that all the research that is done on statins is done by people who have a conflict of interest. The funding comes from the industry and it's paid to the cardiologists who have a conflict of interest because they want to show that the statins work. And there's almost no independent studies because they cost too much to run. And and then let me just finish that up. The National Institute of Health has helped because they have not funded any alternative explanations for what causes heart disease. So if today you have coronary artery disease and you ask, what's the cause? Oh, it's cholesterol. What's the cure? Oh, it's statins. So then you go and look at the science and you say, but actually statins don't prevent it. They don't reverse it. So what else can I do? No, you just take more statins. So it's stopped research for about 40 years. And no one's had the courage until very recently to go and try and explain what's causing arterial disease.
You know what a major thread here is, Tim, is science really seems to be very broken.
Totally broken. And, Robert Kennedy is trying to address it now in the United States, and he's doing amazing work. And he could reverse everything in the next 2 to 4 years. But it is absolutely broken. And I'm sure you've had people on vaccines and so on. And that science is so poor as well because it generates so much income and there's so much interest.
Are you suggesting, Tim, that when we hear about good and bad cholesterol, it doesn't really matter? We shouldn't really worry about cholesterol because if we eat a low carbohydrate diet, whether cholesterol is low or high, it doesn't really matter because we are going to be healthy nonetheless.
Yeah, that's really interesting because there's a study currently going on and it's caused a huge furor because we still don't know the full story. But there's a guy called David Feldman in North America and he began experimenting on himself and he could change his cholesterol from being very bad, very high to being very low in one day.
Yes, I saw that.
1 day. Yeah. Just by fasting or eating more carbs. And so he said, well, clearly your cholesterol's got something to do with energy transfer in the body. And so then he identified a group of people who are very lean, who eat the zero carbohydrate diets and who have astronomically high cholesterol levels. And it's very clear what's happening is that the body transports fat around the body and it uses the cholesterol-containing lipoprotein, LDL cholesterol. The VLDL cholesterol. That's the bigger protein. The bigger lipoprotein. And that travels around the body and it delivers fat to where it's needed. And then it gets turned into LDL cholesterol. So what happens is that this is what's being measured, LDL cholesterol, but it comes from the bigger molecule. And what happens, it seems, in people who eat high-fat diets, is that they produce more of this, and then it travels around, and so they get left with more of the LDL cholesterol. And so but it's all to do with transport of energy around the body, and it's fat energy. And if you put those people on a high carbohydrate diet, the cholesterol drops dramatically. In fact, the funniest study was done by a chap called Nick Norwitz, who is an ex-South African, or his father.
Yes, that's right.
And I taught his father at UCT.
And he ate 24 eggs a day.
Yeah, but this was even a funnier study. So because he's one of these groups who gets this high cholesterol. And he ate 12 Oreos, which are those little biscuits. And his cholesterol came rocketing down, you see, as predicted by the model. So then he went back on his high-fat diet, and then he took a statin. Now it's going to really work. He'd hardly changed his cholesterol. So he said, see, Oreos are better than statins. Oreos are better than statins for lowering your cholesterol. So anyway, the controversy is the following, that when they did the first study of these people and looked at their arteries to see how much plaque there was, they found that was no different from other populations. So that was very encouraging because they had a group who'd been eating the carnivore diet for 4 or 5 years, and their arteries looked just the same as everyone else. They weren't worse and they weren't better, but because there's so many other factors, that was looking good. Unfortunately, they've now studied 100 people, and it looks like, for whatever reason, in the year that's gone, though their plaque increased more than in some other people. So now they're saying, actually, so they published this paper, and all the antagonists to the low carbohydrate diet said, see, your arterial damage is occurring more quickly on the low carb diet or the carnivore diet. And now, within a week, someone had taken those original paper and reproduced it and said, massively rapid increase in atherosclerosis as a result of the carnivore diet. But they weren't even the researchers, as I understand it. So it's very much open at the moment. But the reality is that even if it was more rapid, it was quite slow. The progression was relatively slow. But why is the study important? Because not everyone showed the same response. That's the key. So now they've got a population where they've got some progressing a bit quicker than others. And what's the question they need to ask now is, okay, why are those people progressing rapidly? And why are this group not progressing at all? That becomes the key question. And that's the Nobel Prize winning question, which no one has ever addressed. It's always, oh, well, your cholesterol's elevated, you're going to get rapid growth of, but that we know that's not true, because your cholesterol value is a very poor predictor of how your disease progresses. So this is really exciting work, and at the moment it's being used by the people anti-low carbs to say, you better get off that low carb diet. But let me just come back for the final point, is that we spoke about Kraft and his way of diagnosing diabetes, which was now detects everyone. If you have diabetes or prediabetes, he will detect it. And he said they did autopsies on everyone that they did, if that people died, and they'd got their testing. And he said not one of them didn't have diabetes. So not one of them with arterial disease did not have diabetes. And that's the traditional teaching, is that diabetes is the cause of arterial disease. But medicine has never accepted it, because the treatment of diabetes is dietary. It's not statins. And that's
that guy you mentioned, Nick Norris or whatever. I think he's a Harvard medical student.
That's right.
And he ate something like 730 eggs or 24 eggs per day, or 730 in a month or whatever it was. And then he checked his cholesterol and it dropped by something like 20%.
That's right. Yeah.
Which is interesting, because when I was growing up, there was this fear of eating too many eggs.
Well, Ansel Keys actually published evidence showing that egg intake made no difference. So we've actually known that, but it doesn't fit the model, because there's a bit more cholesterol in eggs. And of course, an egg would be a living being. It's got all the nutrients you need. And cholesterol is one of the key nutrients you need in your body.
But Tim, I don't understand the biology, so forgive me for what might be a stupid question. But if you're consuming, let's say, eggs and it has cholesterol in it, and your body produces its own cholesterol, does it actually absorb that cholesterol, or does it just get rid of it?
No, it does absorb it. But what it does is just produces your own production of cholesterol, so that the total coming into the body will be the same. It's just replaced by what you're taking in. So it doesn't add on, and it doesn't increase above that amount.
Yes, I see what you're saying. But I mean, cholesterol is critical.
Absolutely. Your brain is mainly cholesterol. And that's what people won't tell you, that if the dementia starts after the statins start getting used. So there's been this incredible increase in dementia in the last 30 years, and it exactly starts when they start prescribing statins. And statins absolutely destroy cholesterol metabolism in the cells, and in the brain they will do it. And no one really worries about that, but that's one of the reasons why you shouldn't be taking them, apart from the fact that they're not effective.
I'm going to throw two more questions at you before we come in for a landing. I've kept these two. I've kept these two for last.
I'm up for it.
Okay. This one gets every feather ruffled.
Yes.
And that is fruit.
Yes.
We were always told that fruit is healthy. We must eat lots of fruit.
Well, that is absolute nonsense, because humans co-evolved with fruits that were not what they are today. They were small and bitter. And so if you ate them, you might eat a few bites, but you wouldn't eat what you eat today. So all the fruits have been genetically engineered to be full of fructose and sweetness. And fructose is a real problem because it's metabolized differently from glucose. And it's converted into fat in the liver. And so there are some people who will overproduce liver fat from fructose, and then they get the condition called non-alcoholic fatty liver disease, which is a precursor to diabetes and chronic disease. And fructose is one of the key drivers of that condition. So to tell people to eat more fruit and eat more fructose is simply nonsensical.
Okay, so then by extension, if you go into a store and the fruit looks beautiful, that's probably a bad sign.
Absolutely a bad sign. Yeah, because you're getting a massive carbohydrate load and you're getting a large fructose load. And you can do that for a few years, couple of decades, but eventually the system wears out, because every time you do that, you spike your glucose and you spike your insulin. So the pancreas has to secrete more insulin. And guess what? The insulin has effects throughout the body. And the more you secrete the insulin, the more the cells become resistant to it. So you need more and more insulin to get the same effect. And that's what we call insulin resistance, because ultimately the cells no longer respond, or they respond poorly to insulin. And the problem is that the insulin's acting on all these cells, and sometimes it's a good effect, but sometimes it's a bad effect. Some tissues, it's a bad effect. And that's what resistance is.
Tim, would you agree then that a general rule of thumb is if it's sweet, avoid it?
Absolutely. Absolutely, because it's attacking your brain and it's giving you pleasure, and it's going to be very difficult to stop that. So you're going to overeat calories, you're going to put on weight by and large. I mean, not everyone does, but most people will. And then you're going to want to stop it, and it's difficult.
So if you do want to eat fruit, go for like a gooseberry, which tends to be a lot more sour, for example, than say a strawberry.
Yeah, absolutely. Or watermelon. Blueberries are probably the ones that are most prescribed on the Banting diet. But no, fruit it's an absolute no-no for most people.
Okay, so keep fruit to a minimum. And then my final question, Tim. This is a tricky one. I have a love-hate relationship with this one. Supplements. I don't take any supplements, but I know that some people do. What are your views on this?
I think that supplements are useful, and the reason I say that is because it's an under-researched area, because supplements are not part of the pharmaceutical industry. But I was influenced by a study of where the control group, which was a statin-using group, and the control group were given a multivitamin. And they, as I recall, they did as well, or if not better, than the statin group. And so that surprised me. And there are some other studies of multivitamins seem to be beneficial. But if you simply take it, if most people today have low vitamin D levels, and this was certainly brought out in COVID, that if you had a high vitamin D, your survival was 100%. But if you had low vitamin D, there was a significant mortality. And that's something that you can correct. So vitamin D, to me, is something that could be beneficial. Vitamin K2 usually goes with vitamin D, and that can give you bone strength and maintain bone strength. So those are two vitamins I think that you could make a scientific case, that they would be beneficial. If you're a surfer and you live in the sun all day, then maybe you don't need vitamin D. But for most of us, we spend too much time inside and we don't get enough sunlight. And the other one I think, which is interesting, and I come to it sort of indirectly, that a lot of people say the cholesterol molecule that's important, or the lipid molecule, is ApoB. And what ApoB does is it's one of the firemen that try to sort out problems in the arteries if there's a puncture or whatever, or there's inflammation. And ApoB is a substitute for vitamin C. And humans don't produce vitamin C, whereas many other mammals do. We lost the capacity to produce vitamin C. And so I'm just wondering if maybe chronic vitamin C deficiency, not enough to cause scurvy, could also be behind some of the arterial damage that we see. And so that's the third one that one could take. I personally take nattokinase, which is a kind of a naturopathic statin. And that's got some good evidence that if you're going to take a statin, as many people would like to take a statin, that actually this is a more effective drug and it doesn't have the complications, the side effects. So what I'm trying to say is that there are some supplements that are maybe helpful. And one of the general practitioners who I'm very friendly with, who practices naturopathic medicine, he takes about 25 supplements a day. And he's doing well in his 80s. He's looking fantastic. So that's an anecdote.
So would you say then that if you are able to source grass-fed meat and you spend time in the sun and you generally avoid carbohydrates and sugar, you probably don't need supplements?
Yeah, that's definitely what I would say. And I was saying, if your whole lifestyle is not perfect and the food is not perfect and you're not out there in the sun, vitamin D seems to be a really critical hormone in the body. And the prevalence of vitamin D deficiency is very high. So that seems to me that one could make a good case for that. And I just mentioned vitamin C because it's interesting that humans don't synthesize it. And then I've told you, don't eat fruit, and that's where you're going to get the vitamin C from. So that was probably the other reason why I would say vitamin C might be beneficial.
I said that was my last question, but I lied. I have one more.
Good.
and the reason why this one's coming up is because this is probably a vice. Coffee. What do you know about coffee, Tim?
Okay, well, I have never seen a single study showing that coffee might be harmful. And that's the only difference is caffeineism. Some people get overstimulated, get anxious with caffeine. But otherwise, every study suggests, but again, these are associational studies. In other words, people who take more coffee look like they're a little bit healthier. But that could be because of other reasons. Maybe coffee is expensive and they live in a particular culture and population that is healthy already. And they do lots of exercise and they don't eat processed foods and so on. But on that basis, there's no evidence to suggest that caffeine is bad for you.
We know that in cycling, for example, they considered coffee as a contraband.
I don't think that's entirely correct. What they do say is that caffeine above a certain dose is acting as a stimulant, which it does. I mean, it does act as a stimulant. But they couldn't stop caffeine. And I think Coca-Cola I understand that Coke once upon a time included caffeine, and Coke is one of the big sponsors of the Olympic Games. So there's no way they were ever going to say you can't have any caffeine. So I think there may well be that a little bit that if you really dosed up on caffeine. But like all things, it's not likely that you're going to get better and better and better the more caffeine you take. But to answer your question, there's no evidence for a bad health effect. It does improve physical performance, that's true, but there's probably a limit to how much you need to improve your performance.
But it's so confusing to me because coffee is one of the most popular beverages in the world, and it seems to be a bit mysterious.
Mysterious in what way?
Well, in the sense that they don't really, from what you're saying, they don't really know if it has negative or positive effects on your body.
Well, it's definitely a stimulant, which you could say is a positive, and wakes you up and keeps you active and alert during the day. So I think it probably is highly studied. And maybe what the answer is that no one's come up and said it's bad.
Right.
That's if they'd come up and said it was bad.
True.
Then you'd say it's no longer useful.
Okay, Tim, if I were to ask you for a nugget of wisdom, what would you say?
Well, that's great. I think your lifestyle is very important in your long-term health, and the food is more important than the exercise. But exercise improves your functioning and is terribly important as well. Yeah, it's interesting. I'm just preparing a talk for a schoolboy audience, and I don't know quite where I'll take this, but what's interesting is that what you don't know in life is how people influence your life at a distance. And so it turns out that a lot of people influence my life, but at a huge distance. And I never met these people. And the one person who I only now realized, because I was reading another article, is the guy who started the Nike running shoe business, Phil Knight. Now, why was that? So what Phil Knight did was that in the 1960s, he realized that the German cameras were getting surpassed by the Japanese cameras. And the only shoes of any value in America were German shoes, because you couldn't get Japanese shoes. But he saw that there was a Japanese shoe, which was pretty good. And so he said, will the Japanese running shoes do for running shoes what the Japanese cameras had done for world camera sales? So he went to Japan by chance, and he met these guys who were making these shoes. And he said, oh, well, we've got this big business called Blue Ribbon Sports, which he did not have. It was a complete fake. And we'd like to import your shoes. And so the Japanese said, fine. So they imported the shoes. It took a year to come. And anyway, eventually they started making better shoes. And what did that do? You see, they didn't just make shoes. They suddenly realized it's no good having shoes which you haven't got a market. So he had to make the running market. And what he did was he professionalized running by sponsoring their athletes. And before that, all competitors were amateurs. So the Olympic Games is completely amateur. And the first sort of other sport outside of tennis and rugby, cricket was professional then, or did have professional components. But the only sport in the Olympics that now was becoming professionalized was running. And so eventually the Olympics had to accept professional athletes. Now, what this did was this stimulated sports science. So because now there were athletes who wanted to be trained and they wanted to know how to train better. The East Germans were becoming very successful, and the Americans said, we can't allow the East Germans to be successful. We must invest in sports science. And that became my profession. At the very moment that he was developing the Nike business, I was out there starting sports science. So he had a massive impact on me. So the point of the story is that an individual makes a huge difference. Individuals do everything. They make the difference. So that was the first point. And the other point, which I've realized, is you have to tell the truth. And that's all that's important. And what we've done is expose these untruths. And so when I attacked or showed these untruths through the scientific method, that made me suspicious of all the stuff that we're being told today. And I realized that 90% is propaganda, and it's got nothing to do with truth. That's the second message that's important. And the third thing is to obviously have self-belief. That's one of the things we showed, was that the mind's in control, and you achieve what you think you can achieve. And that's terribly important as well.
Tim, how can I follow you?
Okay, so I'm active on Twitter or X, and it's Prof. Tim Noakes, or at Prof. Tim Noakes. And I also have another one which is more sports related, at Law of Running. And the reason was because I was expelled from Twitter for making the point that a French politician had said none of the other French politicians were vaccinated. But he was charged with something. No, he got injured. That's right. He was injured. He got vaccinated, got injured. And he said, but all these other creeps are telling me to get vaccinated, and they didn't get vaccinated themselves. So I was thrown off for retweeting that story. And it took about 6 months to get back on again. And it was only after Musk had bought X or bought Twitter that I was allowed back on again. So that's the one. Otherwise, the Noakes Foundation and the Nutrition Network, those are the two things that I'm more active in today, having retired 12 years ago or so.
Well, on that note, Tim Noakes, thank you for joining me in the trenches.
Fantastic, Jim. Always a pleasure. Loved enjoying it. Loved chatting to you, and best wishes to your audience.